part of this assignment. A part I did in my previous video, so I'm gonna go ahead and complete the B part. The B part is pulse accumulator gated time accumulation mode. As noted earlier, 68H11 has two PA modes. Other mode is gated time accumulation mode is for counting number of times PA7 is high or low every 64 cycles. This is useful decoding pulse width modulation PWM signal. For this part of this assignment, you need to change the initial value of PACTL in the code so it uses different counting mode. Okay, so this is the one, this is a part of this assignment I did in my previous video, and they are saying here we had to change this value to something different, and that's gonna allow us to complete this one. So it uses different counting mode, and the rest code will still read the results of PACNT along with the higher resolution value every 8192 cycle and display them. To begin, start with A. Okay, so we had to create the same file. We had to use the same file, so we had to use this A part of this assignment. If you want to know how did I do it, you can watch my previous video. We had to use the same one and modify this one. And here let's see what else we need to do. We need to change the input pattern to PA7 as it now PWM signal. Right click and insert the right click in the bit inserter window, select load and pick the beep text, include in the assignment, and then fewer rows will appear. Let's do that. So first I have to get this one, connect inserter, bit inserter, PA7 connected, connect. Okay, then this the window appears. Here I had to load the B part of this and then check the repeat, and then we have to review this one in the serial receiver. That has to be set 125,000 baud rate. Okay, and then firing goes on the assignment, fewer rows, duration. Okay, for this part of the high 64 and all the stuff. Okay, let's read it. File include the assignment. The file has far fewer duration of the stable signal is important, not the number of transitions. If you examine you will see the point transition 1 to 0 doubles from 0 to 1 every 0.8192 cycles. This diagram given, and for this part of this assignment, the PA hardware will measure how often the signal is high every 64 cycles. The expected output should be 0, 1, 2, 4, 8, 16, 32, 64, 128, and then 0. As the pattern stops, we can't go any higher than this 8192 divided by 64, 128. Unfortunately, PWM signal don't provide a lot of resolution themselves, so it's difficult to encode large numbers unless the pulse period is very long, but that limits the potential rate of change. Again, note that the output of the program will be sent to the serial terminal and will be in hexadecimal, so the value should appear as 000, 001, 002, extra up to 0080. Okay, so this is what has to happen. Now let's run this one and see if something happening right now without changing anything. I loaded the B, so it's just printing 1 right now. So I had to make adjustment according to the instruction. I had to just make the adjustment here. The adjustment is basically, now you put the one here, 0 for this one. That's gonna change everything. So now if I reset and run, now I'm getting this 4, 8, 10, 20, 40, 80, and then 0. That's the expected results as it mentioned here. Okay, and that's basically it. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.